here, actually. Sorry. Yeah, actually, I have been working in Helsinki before. I was the director of Climate Info, working very much with consumers. So after that, I moved in 2013 to Stockholm, and I have been working with making Stockholm a more sustainable, smarter city. So I will briefly tell about that project. Stockholm wants to be fossil fuel free in 2040, and that's a different thing than carbon neutral. Currently our district heating is 90% is renewables. So we have 10% left. So we see the challenge in Stockholm being fossil fuel free in 2040 in traffic and transportation. So we're looking very much into when we started in 2014 constructing the project, we didn't have any strategy for a smart city. And when the strategy came in 2016, what we defined was that we want to be not Stockholm City as an organization, but we wanted Stockholm as a place to be smart. Stockholm happened to have the world's largest publicly owned optical fiber network, and the city owns a company called Stokab. So what we had there in the bottom, we have fiber basically everywhere. So 99% of all people and 99% of all companies are connected to a fast connectivity. So we were looking at can we bring sensors on top of that actually city would control or be procuring or somehow in partnerships we will be creating or bringing out there. So we were looking at what part of the city could be wise to do that and start out. So we defined an area called Slakthusområdet, and it's if you probably everyone in Finland knows Globen because that's where the first ice hockey world championship came. So it's the area that is next to that. So it's an old industrial area from the beginning of the 20th century that's going to be refurbished, and 5,000 new apartments and 10,000 new workplaces going to be built there. But we have big arenas. We have Tele2, Globen and Hovet, and they're attracting already now very big masses of people. So it's quite empty in daytimes, and it can be 30,000 people in the evenings or nights. And probably everyone here is a fan of Justin Bieber. I mean, yeah, we are not at all. So when Justin Bieber came to this particular area, it took 4 hours to empty the arena area. 4 hours. So kids were looking for parents. No mobile phones were working. They didn't know where they were. So they were running over highways looking for mom and dad. Mom and dad obviously came from all around Sweden to bring the kids with cars to the place. So the huge traffic jams, lots of congestion and all. So that was something, and that was also the initial point. Could we figure out beforehand, collecting with sensor data, what kind of events can cause this kind of traffic congestion? Could we then inform people beforehand about this? So that was one of the origin points. Another thing that we realized was there's a large parking area underneath the Tele2 arena, and when people come from the north of Stockholm into the parking, they tend to also drive out from the same exit. But to exit the arena, they have first to go south into a roundabout, and then they go north, and causing once again they stop the traffic in the tunnel of Söderles tunnel, almost all the way to the Essingeleden. Can cause traffic, and it can be a Sunday afternoon. People come back from the summer cottages, and suddenly there's a huge traffic congestion Sunday afternoon that you didn't know, just because these people are exiting in the wrong. So could we inform these drivers to take the other exit, so you don't cause this kind of traffic jams? So it's very much about the information. So that was kind of the origin point. So we started with, okay, what kind of sensors could we have there? What kind of platforms would be used? What kind of artificial intelligence or machine learning could be wise to do, and what ways could we communicate with people? So that was kind of the origin point what we started. Working across different organizations within the city and departments, and also seeing that, okay, we defined that we're not going to look anything about energy efficiency. We're going to see how can we reduce the transport emissions, can we reduce congestion, can we increase the quality of life for them visiting the area, but also living and working there. And can we in some way create also economic growth or efficiency in the city resource? So we wanted to have a shared open platform. Basically, being able then to invite other actors to use the data for different kind of purposes. So we selected a set of sensors that we believe could be used for many different purposes. So we wanted, okay, this information can be used by us in the city, it can be used by traffic planners, city planners, it can be used by city decision makers, but also different kind of private actors. And we believe that you can also develop different kind of application for users and consumers. So that was kind of the origin point. Very much think about what kind of sensors and what kind of data can gather that can have multiple uses. And so we ended up in using two types of sensors. So we have this kind of sensor that is a Swedish-based company called Facility Labs that basically it's not anything difficult. I mean, they're reading camera sensor plates, but the difficult thing is to anonymize that because you cannot store private information. So what they gather is that we get a digital hash, and then they're running that digital hash against the transport authorities' all registered vehicles in Sweden. And based on that, we get all the information that in the transport authority, except we don't know who owns. If it's a private person or company, we don't know who owns that. We don't know what address it is. We don't know person numbers or organizational numbers. We know if it's a woman or a man. We know in what postal area code that vehicle is registered and so forth. So that kind of information. But obviously we also know if it's a hybrid, if it's an electrical car, it's a cargo car, if it's a bus, if it's a taxi, whatever it is. So we get very, very rich data out of that sensor. And the other thing is that we also put Wi-Fi sensors to register people movements, pedestrians, bicyclists in the area, how they move, how they come, do they come by bus, subway, do they come by car, how do they exit there, and so forth. And then we also saw that weather data is really, really essential in this knowing, do people choose bicycling, walking, public transport, or car driving? And is it affected by the weather or by other circumstances? For instance, to find out what kind of modal transition or division will be for a certain type of event. Is it dependent on the weather, or is it dependent on who is actually performing? So if it's sunny and Justin Bieber, or if it's like really winter and Justin Bieber, is there any difference? So that kind of issues. So what we created was a zone. So we have 4 points where vehicles exit and enter the area. So we get an overview of everything going in and out. And then we have, original our plan was to put up 45 Wi-Fi nodes. We have currently up around half of them. And very much in the area of where the arenas are. And also there, it was a matter about when a person with a mobile phone passes this kind of Wi-Fi node, there's a MAC address or a signal, and then we can see that, okay, what path have they walked, how fast have they gone, and so forth. And obviously, we have to also anonymize that data. So everything goes into this kind of platform. I mean, you have IBM's platform is one of them. There's obviously many others. And I think that one let's see if there is. Okay, I will go here and show. So we were looking very much in this end. So we started with traffic analysis of a city. So we started with the users. So there were people with data science experience. So what kind of data do they want to work with? What kind of tools do they want? What kind of functionality do they want? What kind of data do we have to bring in, and so forth? What kind of enrichments, analytics we have to perform? The next step would be more conventional users that are not scientific about that. It can be a planner in the city wants to do that. They can use very much of the tools also already existing in the platform. We were also looking very much on dashboards. I mean, understanding not only about the data, but also about all the sensor or the functioning or the providing data. Is some of them down and so forth? So unit handling dashboards were created. And then we were looking at, could we create also different kind of web applications with third-party applications and to end users. So we were looking very much on the user side and user needs, and based on that we define what we want to do in the platform. And I think that is quite different approach. And we're working very much with design thinking workshop and so forth to define what the user needs, what kind of who are the users overall, and what do they need, and what would be good to develop. So my role actually in this project was what we saw, that this has to be a close cooperation with the city and in this case IBM. So IBM had a development team, and they have a Scrum Master, they did sprint sprints, and I was 50% product owner, and another 50% was from IBM. So we were working very closely, and my role was very much to work with the users of the city. So I think that this is also something that you need to think when you want to create a smarter city. You need to completely crash and start really new thinking about how you cooperate, how you co-create things. You cannot just be procuring someone else to do the things. You have to really get involved and be part of the process. So that was something we were doing. And here are just some example of graphs of showing how they're fluctuating between different sensors and passages per minute and so forth. We can see that, okay, what are the carbon dioxide emissions of passing vehicles, so we get an idea what categories they are. So we can, for instance, see it's very small, but it's the largest category is from 100 to 150. We can also see that, okay, how many cars, for instance, are hybrid. And another thing that we have a shift of political majority now. So we have the red-green majority, and now we will have a blue-green, actually. And the blue-green majority has defined that they want to create environmental zones in the city of Stockholm, meaning that you will somehow restrict vehicle traffic into those zones. Currently, you don't know anything about the vehicle traffic. You just know the amounts. You don't know what type of vehicle. With our sensors, we can define, is this a Euro Class 5 vehicle entering the area, or is it a 6, or is it a 3 or a 4 or whatever? And what we are doing, or have done, is that we have combined with air quality measurements to define a correlation that what type of vehicles is actually causing, for instance, problems with particle emissions or nitrogen oxide emissions or whatever it is. So really get define and see what time of the day and who is the problem, what is the problem. And maybe it's so that you don't need to restrict fully all cars during the whole year. Maybe you need to restrict them, part of the vehicles in part of the year and part of the day or so forth. This kind of information is crucial in defining a more adaptive environmental zone. Because conventionally you just ban everything that you don't want and then you hope for the best, but you don't follow up that. Did it have effect? Was it true? And so forth. So this is a bit different approach, for instance, what is happening in German cities. So this is something we can also do. We can also, as we know the vehicle type, we can address directly drivers. You can say that, hey, great, you're driving an electrical car. You're part of our ambitious goals to be fossil fuel free. We can direct also messages, for instance, that we can tell that these trees will be prohibited for this type of car, so we will put a fine on or a payment for this. So that we could introduce that very early on, so maybe you have 1 year time to change your vehicle into something else. So it's not a surprise when you suddenly say, oh, I cannot enter it, it's bad. We can also direct people, for instance, I was telling about the parking thing. We can tell, are you going north? Please park in this part of the parking hall and exit this way. So we can also, if the car is registered in the northern post numbers, we can give that kind of information. We are also looking at, could we use this kind of flow analytics from pedestrians to define pre-program, for instance, the lights in the event area. So we know that, okay, this is a Justin Bieber event. It will take 4 hours to empty the arena afterwards. Then the lights have to be stronger, much longer. Or we will know what kind of path they want to walk to exit, for instance, to the subway stations or whatever. So we could pre-program, used on the flow data, we could say that we know that event type, okay, this is this type of event. People tend to come, for instance, to football matches 1 hour earlier, so we would then build up the lighting system based on that. So it would not be standard from one event to another or standard from one day to another. You can also look at very much of connectivity and connect street lights and see that where people are, where I was mentioning about Justin Bieber, there was not enough connectivity. You need to raise that connectivity. So where do people tend to be or stay, you would need there much better connectivity, for instance. Then you could define that previously or before. And then we also did in the summer, I was talking about the applications. So based on the data of Wi-Fi, and also already existing open data in Stockholm, the IBM developers developed application that you can in real time see, okay, where are people? If you want to take the subway home, which subways, there's 6 of them. Which should you take? Which is the fastest way? So combining both flow data of the area to also see public transportation information. So this is also a congestion prediction information that you can see before you enter, that you can see, okay, there's this kind of congestion, the prediction is like this. So you get quite much value added information both before and after events. So that's something that we have developed based on the. So as was mentioned before, I mean, what do you want to do? I mean, you don't want just create pilots, you want to do something also afterwards. And we're now looking at could we add different data sources that is already there. For instance, we know that there's parking data gathered in a global parking area. So can we analyze that and get that in the same platform as we have? That could be analyzed, it would give more richer data. And we are also looking at adding camera-based sensors that are not defined to, for instance, read registration plates. They could do different kind of things. So we want to know, I mean, what is the problem with GDPR? I mean, how do you analyze that? You want to just collect the data. How can it be stored? How could it be flowed? What kind of data amounts is there? What kind of connections do you have? So that's something we are going to introduce and run the data into the platform, and then we use different kind of AI analytics and machine learning to define, for instance, this is a cat, this is a dog, this is a pedestrian, this is a bicycle, this is a cargo, this is a bus, and so forth. But we can also look at, is this a queue of bicycles or is this a queue of vehicles? And another step is that information could be then used to steer traffic further away. For instance, we see that there's a congestion going to happen in half an hour. Could we then steer traffic lights 3 kilometers away that restricting vehicles to entering that area? So that kind of predictions could be also done based on that kind of data. So that was a very fast introduction to what we are doing in Stockholm. We are organizing very much study visits. So if there is any interest of visiting, and there you would be able to see all the 21 smart solutions we are implementing. So we organize pretty much of them. So it's just to contact, and I'm writing a blog and a website, and there's also newsletters. There's fact sheets about our smart solutions, not only in Stockholm but also in Köln and Barcelona, that are 2 other lighthouse cities. So there's pretty much going on, and so it was mentioned that this Helsinki started in 2016. So we started we were among the first ones, or one of the first ones. So we started in 2015. So this is the 4th year, and next year is the last year of our project. Thank you.
And thank you very much, Mika. Hold on to the microphone and we'll get a few questions if there are any from the audience. Thank you so much for the really in-depth presentation.